Today's lesson is on ellipses, and we'll be graphing them. My learning objective is I can graph ellipses with their critical points, and those points are the center, the vertices, the co-vertices, and the foci. Where do I really see these? I see these in the real world in astronomy, not only just orbits of planets, but comets. I see these in chemistry as electrons moving around the nucleus of an atom. I see this in medical machinery. This is where they're used to break up kidney stones. I see this in the Roman architecture with the Roman Colosseum. Okay, by definition, an ellipse is a set of all points such that the sum of the distances from any point of the ellipse to two fixed points remains constant. These fixed points are called the foci of the ellipse. So foci is plural for focus. So my 2 points here are the focus. So if I would put a string in between these 2 points and move it around the circle, the string would remain constant and I would be creating this ellipse. So the D1 plus D2 is what remains constant. Okay, let's go through some vocabulary. So the major axis is the longer axis of symmetry. The minor axis is the shorter axis of symmetry. So in this example, the longer axis is the x-axis, and the minor axis is the y-axis. The center is the intersection of the major axis and the minor axis. And the vertices are the endpoints of the major axis. And the co-vertices are the endpoints of the minor axes. So these are co-vertex and co-vertex. Okay, this is vertex and vertex and co-vertex. Okay, I can have horizontal or vertical ellipses. So we got some standard forms or standard equations. So for a horizontal ellipse, my equation is x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. And going through here, the vertices are plus or minus a units away from the center. So here's my center. So a vertex is plus or minus a units away. So here's a vertex. Here's a vertex. The co-vertices are plus or minus b units away from the center. So here's a co-vertex. And here's a co-vertex. And a and b are the denominators in the equation. So that would make the length of the major axis 2a. So a plus a is 2a. And the foci are plus or minus c away from the center. So the foci are c plus or minus c. So this is, here's the foci. So this would be c. This would be c away from the center. So if I move this A and I form a triangle, I'm going to move the A here. So this would be A, B is a leg, and C is a leg. Okay. So I'm going to have a right triangle here. So the formula to find C, because I know A and B from the equation, so I'm always trying to calculate C. So C is a leg. So C is going to be the hypotenuse, which is A. So this is going to be C equals the hypotenuse, the square root of the hypotenuse, which is A squared, minus the other leg, B squared. So C is a leg, and I need to know that A is the longest side. So even though I am using the Pythagorean theorem, C is not the longest side, and I need to pay attention. Okay, so same thing for my vertical ellipse, but this time I have x minus h divided by b. So whatever a squared is, I know that's the major axis. So the larger number is the major axis. So the major axis is under y. So this time I have a vertical ellipse. So here is A. So I know the major axis is 2A. So the major axis is 2A and the minor axis is 2B. And the minor axis is 2B. Okay, so C in this equation, so if I'm drawing the foci in, this would be C, and this would be C. So if I want to move my A distance, so it's going to go from the focus here. So here's my right triangle. So again, the hypotenuse is A. So my leg is C, my leg is B, and the hypotenuse is A. Okay, so when I'm graphing an ellipse, I'm expecting to see 7 points. I want to see the center. I want to see 2 vertices, 2 co-vertices, and 2 foci. So I'm expecting to see a total of 7 points. Okay. When I am naming the points, I want the exact values, but for graphing purposes, I need to round. But when I'm stating points, I want the exact value. All right, so let's do an example here. Graph each ellipse. Identify the center, vertices, co-vertices, and foci. So I am looking for which has the larger denominator. So in this case, it's 49. So that's my a squared. So a is the square root of 49, which is 7. So b squared is 9. So that makes b equal to 3. So my center is at HK. So HK is -1, 2. So I'm going to graph that. So -1, 2. And then we said, since the larger number is under X, I know I have a horizontal ellipse. I know I'm in standard form when I'm equal to 1. Okay, so my A value is my major axis. So here's my major axis. Here's my minor axis. So A is plus or minus 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. These are my vertices. So my vertices, and I would usually show these from least to greatest. So these would be -8, 2, and 6, 2. My co-vertices are plus or minus 3. So 1, 2, 3, and 1, 2, 3. So again, I'm going to show these least to greatest. So -1, -1, and -1, 5. I need to calculate C to find my foci. So we said C squared equals A squared minus B squared. So C is, so A squared is 49 minus 9. I'm going to take the square root. So C is the square root of 40, which if I'm simplifying this is going to be 4 times 10. So this will be 2 times the square root of 10. And if I round that, that is going to be 6.3. So I'm going to use the 6.3 for the graphing. So 1, 2, 3, 4, 5, 6.3 is going to be over here. And 1, 2, 3, 4, 5, 6.3 is going to be right over here. Okay, so I'm going to kind of sketch my ellipse in. Here we go. Okay, so my foci are from the center plus or minus C. So my center is at -1, 2. So I'm at -1 plus or minus C. So plus or minus 2 times the square root of 10 and 2. Okay. We are done. If it helps, you can draw in your triangle on one of them and show what everything is. So I know A is the hypotenuse, C is to the foci, and B is on the minor axis. All right, let's do another problem. Okay, for my equation, my larger denominator is under y. So that tells me I have a vertical ellipse. Okay, so I know A squared is 36, so A is 6. B squared is 20. So the square root of 20 is 5 times 4. So that is going to make B 2 times the square root of 5, which is approximately 4.5. So my center is at H and K. So H is -4 and K is -2. So -4, -2. So my major axis is vertical. My minor axis is horizontal. So my major axis A is plus or minus 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. B is approximately 4.5. 1, 2, 3, 4.5. And 1, 2, 3, 4.5. Okay, I'm going to sketch in my ellipse. There we go. So the vertices are at -4, -8. So -4, -8, and -4, 4. My co-vertices, so I want exact answers, so my exact answers use B. So I'm adding plus or minus B. So my co-vertices are the horizontal amount, so this is going to be at -4 plus or minus 2 times the square root of 5 and -2. And my foci, I have to calculate C. So C squared is going to be 36 minus 20. I'm going to take the square root of both sides. So C equals the square root of 16, which is 4. So my foci are on my major axis and up and down 4. So 1, 2, 3, 4. And 1, 2, 3, 4. So my foci are at -4, -6, -4, -6, and -4, 2. So I can sketch in if I want to have an idea what my triangle is. I know A is always the longest side. B is to the co-vertex. And C is to the foci. I have 2 more examples. Okay, what I'm noticing now, like look at example number 3, is I don't equal 1. So when I don't equal 1, I need to divide so that I am equal to 1. So I'm going to divide each term by 144. So when I simplify 9 divided by 144, that's really going to be x squared divided by 16 plus y squared divided by 9 equals 1. So now I equal 1. So I know my a squared is 16. So that means a is 4. B squared is 9. So b equals 3. My center is at the origin at 0, 0. Since my larger number is under the x-axis, I know I have a horizontal ellipse. So I'm going to add 4 horizontally and 3 vertically. Okay, so my vertices are at -4, 0 and 4, 0. And my co-vertices are at 0, -3 and 0, 3. My foci, so c squared is a squared minus b squared. I'm going to take the square root of both sides, so c equals 16 minus mine, which is the square root of 7, which is approximately 2.7. So c is approximately 2.7, so 1, 2, 2.7, 1, 2, 2.7. So I am adding or subtracting from the origin, so this is plus or minus the square root of 7, 0. Okay, last example. I do not equal 1, so I first need to complete the square on this one. So I'm going to do x, oops. So I'm going to do x squared minus 10x plus something plus y squared equals negative 9 plus something. So I'm going to take half of my b term, which is 5, and square it. So that's 25. So I'm going to add 25 to both sides. So this makes this x minus 5 quantity squared plus y squared equals 16. Now I'm going to divide all the terms by 16, so I equal 1. So this is x minus 5 quantity squared divided by 16 plus y squared divided by 16 equals 1. I'm sorry. This is going to be because I had a 4y squared here. I missed this here. So 4y squared, so this makes this y squared divided by 4. So my larger number is 16, so I know I have a horizontal ellipse because my larger number is under the x coordinate. So I know a is 4, b squared is 4, so I know b is 2. So my center is at 5, 0. At 5, 0. Okay, my vertices are plus or minus 4. So 5 and 4 is 9. And I'm going to go up and down 2. 1, 2. 1, 2. Okay, and then I have to calculate c. So c squared is a squared, which is 16, minus b squared is 4. So c squared is 12. I'm going to take the square root of both sides. And this is going to be 4 times 3, which is 2 times the square root of 3, which is approximately 3.5. So I'm going to add 3.5. 1, 2, 3.5. 1, 2, 3.5. So if I draw in my triangle, A is the longest side, B is to the co-vertex, and C is to the foci. I don't think I drew them on here, so let's draw these in. So I'm going to add these. It just helps me visualize what I'm doing here. So here's C, A, and B. Okay, that's it.